comment on a podcast by Rodney Brooks at the Lex Friedman podcast. He was talking about robotics, intelligence, and I think the main problem I have with Rodney Brooks is not about the subject matter. I would not dare try to criticize a seasoned professor of robotics about robotics or AI. I don't want to do that. I have a problem with epistemology. I have a problem with the way he's arguing. And I think on that front, I am either more qualified than him, or he's maybe just pretending not to know what kind of mistakes he's doing. In particular, he's using induction as justifying his beliefs, and I emphasize the word beliefs here. This is not reasoning. This is not the scientific method or any of that stuff. He seems to have an agenda, and he's using induction and also bandwagon reasoning, and I'm going to explain what that means in order to justify certain beliefs which are orthogonal to a lot of what people are thinking right now in the AI community. This is Not Even Wrong podcast. It's September 4th, 2021. This is Krim Delko. It's a Saturday. There's no update. We're still up for the year, 15.3%. The market's up 20.7%. We're underperforming by 5.4%. There's a correction from yesterday. I said we're underperforming by 5.3%. We're underperforming by 5.4%. So it's a Saturday. There's no update. Nothing has changed on that front. So I want to talk about this podcast now. Rodney Brooks is a seasoned robotics professor. He was at MIT. He's a well-known figure in the community, and in particular, let's call it from the old times, from the pre-neural net deep learning times, when robotics was still more of a hard-coding, explicit knowledge type of science. And I think this is already the first problem. I feel a little bit of an aggravation. I feel some tension in his arguments, and I just can't help but wonder, is he just jealous? Is he trying to play down all the achievement that the kids, let's say, in a sarcastic way I mentioned that, but the newcomers in this field have achieved in robotics? Could this be just an old grumpy man being a little bit grumpy about the achievements of a whole new generation of scientists and also practitioners in the robotic space? I think Lex is a good example for that. He himself, I would say, is more of a new kid on the block. He has achieved tremendous success as a media, as more of a reporter. I don't want to diminish his role, but he seems to me a lot better at reporting and interviewing people than at other things, and that's his success. But no matter what, the point here is that it looks like there's an old guard of robotics people, and they all have their roots at MIT, Carnegie Mellon, places like that. And there's a new guard, and that new guard sort of sprouted out of Jeff Hinton's lab at Toronto, Yasustaver. Then we have Jan LeCun's lab at New York University, Wojciech Zaremba. We have other people, let's say, Peter Abil coming out of Stanford. So you know, Andrei Karpathy, Fei Li's lab. Those are people that have been in particularly successful with vision, using neural nets in the realm of vision, and now vision is sort of translating into robotics. And I'm going to talk about this a little bit more. But I want to get back to my point here about Rodney Brooks, and I think the fundamental problem I have with him is that he seems to be dismissing a lot of advances in recent breakthroughs in AI, in particular what Tesla's doing with the car, what they're doing with vision, and also what the vision is of companies like Tesla and others to start using vision-only, camera-only based, neural net-based reasoning in terms of building a model around the world. And then also he was dismissing AlphaGo Zero, which is the other piece of the coin, which is the self-learning part that I think will play a much bigger role going forward. He was dismissing all of these things, and he was using induction. He was reasoning by induction, which means he was saying things like, well, this was done in the 80s, this was done in the 90s, and we didn't see success, and therefore we won't see success going forward. This is a typical Bayesian approach, reasoning by induction, and absolutely useless when it comes to disruption by when it comes to the application of fundamentally new concepts, because that's the whole point. Like, they are actually breaking with the old. They're bringing in new concepts, new engineering practices. They're building new innovation stacks around things that haven't been done before. So to go and say this will not succeed because such and such in the 80s tried it, didn't do it, or such and such in the 90s did something. It's a futile argument. It's a void argument. It's vacuous argument. And I just can't help but wonder, he has an agenda here. The same other things, particularly when it comes to Tesla, for example, he was bragging about coming to this interview with a Mercedes, and he was saying how great the whole, let's say, vision system of the Mercedes is and all that stuff. And maybe that's true, but please, how much does that car cost? Maybe if you have an ultra luxury Mercedes, you might be able to see, I have a very nice vision, but you know, you pay $150,000 versus what the Model 3 is giving you for $35,000, $40,000. It's just two worlds, and I think this needs to be acknowledged at this point. So again, I don't want to question Rodney's actual views on robotics here, because again, I would not dare try to even have a conversation about who's right or wrong in this type of space. Here's what I'm trying to say here fundamentally is that I think the reason we are so excited about vision, neural net-based vision, and also neural net-based and self-supervised reinforcement learning-based self-learning as the future forward for physical objects moving around in nature using intelligence. The reason we're so excited about all of this is because it is cutting with the past, going into the future with a new, fresh approach, with new, fresh concepts, and therefore reasoning by induction just doesn't work. And this would be the first thing that I want to point out, and also use as an example of why one shouldn't do this. It's not healthy in any kind of conversation, in particular not when it comes to technology and science, because it just doesn't help you if you say there was a piece in this interview where Lex was talking about AlphaGo Zero, which is just, I think, the biggest breakthrough in any kind of artificial intelligence, in my view, at all, since humans exist. This is even better than Turing. And they did it. They did a fully based self-learning approach towards playing Go, and that model not just beat the best humans, but also all the other systems, the AlphaGo systems, which are based on external knowledge, on explicit knowledge, and on hard-coded knowledge. And that system even beat that type of Go system. And then Rodney Brooks, all he could say is something like, well, this was all in the 1960 paper by XYZ. And then even Lex kind of said, like, come on, please. Like, you're telling me that somebody in 1960 mentioned a few concepts, and you're equating that to the engineering fulfillment, to the actual instantiation of all these concepts into an engineered system, which actually delivered a win in a very complicated situation, namely Go. You can't do that. This just doesn't work like that, because it's not helpful. It doesn't really get us anywhere. I mean, if you tell me, that, for example, you know, I have a car right now that can drive me from my home in San Francisco to Lake Tahoe with almost no intervention. And you tell me, well, this is useless because in 1975 somebody had a concept car that did the same thing. I don't even know what to do with a statement like that. I'm buying a commercial car for a very reasonable price, by the way, way cheaper than anything else comparable, even outside of the AI technology. And I have this luxury of not having to deal with lane changes and lane keeping and all that. And you're telling me somebody in the 40 years ago wrote in a paper some conceptual stuff that is similar to this is ridiculous. So I think this is I would call it reasoning by induction. And I also have another word for this, detailizing, which is you're just throwing details, you're throwing names, you're dropping names of some researchers that nobody has ever heard of, in terms to say, well, this has all been done before and it has not led to anything, so it won't succeed. I think this is an unfortunate example of when people have an agenda. I would say an alternative agenda here. This is not somebody that comes with a clean, fresh view of the world, trying to discuss, okay, what's going on, what are the advances, what's happened in the world. This is somebody that comes with an agenda, is trying to put down certain things and trying to somehow put other things, namely these old approaches, these explicit approaches, try to put them somehow still in a limelight when they really are gone. Now, having said all of that, I want to just use this episode also to set the lay of the land as far as we're concerned. So there are basically two directions that the AI community is going. There is the old and the new. The old is rooted in principles that people like Rodney Brooks have created, and kudos for them. Without those people, we wouldn't be where we are today. They have created what's called expert system. They have doubled down with neural nets. They have worked with symbolic logic. They have done a lot of things that they had to do in those days because they were limited with compute, and they also didn't have the certain neural net and algorithmic knowledge that we have today. So they were trying to solve problems. They didn't have the tools, and they also didn't have the knowledge to solve those problems. Then came along, let's call 2012 ImageNet as the breakthrough. I know it's not that simple, and I don't want to take away from other people, but let's just use this for simplicity. 2012 ImageNet, Jeff Hinton, Ilya Sustaver, and others write a paper where they say that we solved image recognition with pure neural net type technology. They win by far reach and create this revolution. But what we call today machine learning is basically based on all of that. And the idea is that we can have machines use certain neural nets, certain algorithms without explicit knowledge and explicit programming, and then sort of program themselves by just being fed data and learn from the environment whatever task they need to do, for example, recognize cats or things like that. So this is sort of where we are today, and I think Tesla is taking this to the next level, where they're going for vision only when it comes to the part of the car that needs to see. And in terms of creating any kind of intelligence, in particular the physical type, so when you have a robot actually going in the real world, you need two things. You need a model that recognizes the world, in other words, tells you where you are and what's going on around you, and you need another piece which we call control and planning, which is you need something that tells the thing, the car or the robot, what to do next. And those things are very complicated. I'm trying to simplify it here. The what to do next part is, I think, where the next, I would say, level of the revolution will happen. And we see that in the following way. We think that self-learning is actually the key towards the next leapfrog here in terms of just results, in terms of seeing robots doing things that we couldn't even imagine before. What we need for self-learning in the physical world is, unfortunately, we need a step in between, which I call sophisticated video animation. So we cannot have video animation. First and foremost, why do we need video animation? I think it's pretty obvious. We cannot have a robot go out in the wild and learn by self-reinforcement, because it's going to go and kill people until it figures out not to kill people. So we can't do that. We need a realistic video animation where the robot can, or the model, excuse me, can self-learn through self-supervised reinforcement learning, and then those models can be used in the actual robots, and then they can use them as inference to act. So what that means in particular, let's say for Tesla, is that at some point, and we predict that in the next 5 years, we will have an announcement where they say that we're going from explicit task-based learning towards full self-learning, and then the car will actually do much, much better, orders of magnitude better than even the cars before, and humans for sure. In order to get there, though, we need to have a realistic animation, video animation. This is the problem, because, again, we cannot have animation a la conventional video games and all that stuff. And Elon Musk has said that in the last AI Day, not this one, the one 2 years ago or 3 years ago, where he said that animation is not good because it cannot actually realistically mimic the real world. Now, if you have concepts like DALL-E or concepts along those lines, which is what OpenAI is working on, and I was incredibly excited to see what Wojciech Zaremba is doing, because I think he's on that path. He's a lead robotic researcher at OpenAI. The concept is the following. You have a success with GPT-3, which is a transformer that can literally help you predict text in a way that it's very realistic. In other words, I can put in, let's say, give me a conversation between Abraham Lincoln and Elon Musk, and that thing would actually mimic a conversation based on all the millions and millions and trillions of iterations it's done learning text from the internet. It would be pretty good at predicting a conversation between these two people. Now, in that realm, DALL-E is trying to do the same thing with pictures. So what that means is that we could have a video animation where we show, let's say, I see a road in Alaska, and then the DALL-E just keeps creating an animation of that icy road with all the stuff that potentially, well, most likely would happen if you drive somewhere around Fairbanks. And this is the key to self-learning. Imagine if we could have a concept like DALL-E or something along those lines that can create realistic video animation based on learning. Again, this is the key. It's based on a massive algorithm with massive learning and massive compute that has learned to animate the world based on real pictures, but then learned from those and is able to animate, predict the next frame, and so on and so forth, to create a realistic video animation. And if we had a realistic video animation, we could then use self-learning for the car in self-supervised reinforcement learning to actually become much, much better. Why? Because we could have trillions of iterations. We are only limited now by Moore's law, by compute power, because all we and in this context, compute power is just another word for try and error. And the more try and error we can have, the more compute we have, the faster we can iterate, the better we can get at actually figuring out how to drive. And then eventually we could have a self-learned system which drives not just much better than humans, but also very different than humans. This is the key, because this model has no explicit knowledge infiltrated through us. It's not biased by human driving, and therefore could do things that we humans don't even think about and be much better. The same way AlphaGo Zero is doing that right now for AlphaGo. So to conclude, I just want to go back to the beginning of this episode. I am quite disappointed with Rodney Brooks' interview with Lex Friedman, in particular because he's using induction as a model for reasoning. I think it just feels like he has an alternative agenda when he's reasoning about trying to sort of put down what's been achieved and trying to put things from the past in the limelight. Again, I don't want to think of any kind of conspiracy here. I just want to say that it seems to me that reasoning by induction just doesn't work when it comes to these types of disruptive technologies, and that we believe that not just are we at a great position right now in AI and robotics, but we have a huge, exciting future in front of us based on realistic video animation and self-learning as the next step to create robots, real-world robots, using intelligence to navigate in the real world. Thank you.